Hello, AB students. I'm going to be going over some of the problems from set 3 multiple choice questions on differentiation. These are the problems that I'm going over in this video, number 1, 17, 44, 51, and 75. So let's start with number 1. Okay, so we've got y equals 4x plus 1 times 1 minus x cubed. First thing I notice, we have a product rule happening, but within that we've also got a chain right there. If this was a plus x, there wouldn't be a chain. However, that minus x, that subtraction there is going to result in a derivative of -1. We're going to have to remember the chain rule. So as I find the derivative, let's start with our product rule first. I'm going to look at the first one in blue, the second one in green, since I already did some green there, and product rule, we're going to take turns. So I'm going to do the derivative of the first times the second, and product rule uses a plus. Now I leave the first alone, and I multiply by the derivative of the second. Okay, so the derivative here, we've got a power rule happening. So 3, leave the inside the same, subtract 1 from the exponent, it's power rule, and then chain rule. I need to multiply by the derivative of the inside function. The derivative of 1 minus x is -1, because -1 is the slope of that line. Remember, the derivative is the slope. So let's see if we can simplify this down. Okay, I notice that both of the terms, remember terms are separated by addition. They could also be separated by subtraction, because technically that's adding a negative. Terms are separated by addition. Each term has a 1 minus x, and looks like 1 minus x squared is within each term. I'm going to factor that out. So I'm going to look at this 1 minus x quantity squared, factor that out, and see what we're left with. We're left with a 4 and another 1 minus x, because this was cubed. If you factor out the squared, there's another left over. Okay, and then we have a plus. Over here, this is factored out, the 1 minus x squared, but we still have a 4x plus 1. We still have a times 3 and a times -1. So that's what's happening there. I'm going to scroll up. Okay, our y prime. 1 minus x quantity squared. Let's see what's happening. Okay, distribute here. I've got a 4 minus 4x. Okay, I am going to change that plus to a minus because of the negative happening there. So minus, and then let's distribute. 3 times 4 minus 12x. And minus again, we're subtracting both of these because the negative happens to all of it. 3 times 1. Okay, let's combine like terms inside there, see what we get. Y prime is, we've got 1 minus x squared. We have 4 minus 3, 1. Minus 4x minus 12x minus 16x. And then let's look and see if we can match that up with anything. Option C was 1 minus x quantity squared, 1 minus 16x. Feeling good. How you feeling? I hope it's good. Okay. Oh, let's keep going. More to do. 17. Okay, we've got y is the natural log of e to the x divided by e to the x minus 1. Okay. So the beautiful thing about this is that you've got a natural log right next to some e to the x. I'm going to use log rules, simplify this down, make it so that I don't have to do chain rule combined with quotient rule. Sounds delightful, right? It is. Okay. So separation here. If you're dividing within one log, that's subtraction of 2 separate logs. I've got the natural log of e to the x minus the natural log of e to the x minus 1. That's what's happening. Okay. And you know that ln's undo the e's. It's good stuff. That's just x there. So our actual function, before we even take the derivative, is x minus the natural log of e to the x minus 1. Now this natural log cannot undo the e happening there because of the subtraction of 1. This cannot be split up, can't be simplified. We are going to have to do a little chain there. But not quotient rule, yeah? Okay, let's find y prime, derivative. The derivative of x is 1, because that's the slope of it, minus. The derivative of natural log of something is 1 divided by whatever's in the natural log. And now I've got to do a little chain rule, take the derivative of what's inside. And we always multiply by the chain. And that multiplication always happens in the numerator. So the derivative of e to the x minus 1 is e to the x. Because the derivative of e to the x is e to the x, the derivative of 1, that's a constant. Its derivative is 0. Well, oh my, let's see. This looks like 1 minus e to the x over e to the x minus 1. Let's see if that matches up with anything. Well, no, it doesn't. So, let's see if we can get a common denominator happening right there. Okay, 1. That's the same as e to the x minus 1 over e to the x minus 1, right? Something divided by itself is 1. And then we're going to subtract e to the x over e to the x minus 1. Yeah? Well, that's kind of nice. Because if we take e to the x and subtract e to the x, boom, that's 0 right there. So we've just got a negative 1 happening on top. Negative 1 over that denominator, e to the x minus 1. Remember, you can only subtract the numerators if the denominators are the same. So let's see if that matches up with anything. Oh, yeah, it does. That's option C. How you feeling? I'm feeling pretty good. Okay. Let's keep going. After 17, let's find the next one that we're doing. Oh, it's a bit 44. Okay. Let's start with purple. I haven't used enough purple yet. 44. X plus the cosine of x plus y equals 0. Okay, I picked this one to show you specifically because when I passed out the papers and asked you what you wanted to review for the AP test, what you weren't feeling real strong on, a big one that you said was implicit differentiation. So I wanted to pick one of the harder implicit differentiation problems in the packet to go over. So let's take a look at this. We're going to find dy dx, but the y is all mixed in with everything. This is not in function form. So I'm going to have to do a little chain there, an extra chain for the implicit. Let's get started. Okay, derivative. The derivative of x with respect to x is 1. The derivative of cosine of something is negative sine. So let's change that plus to a minus. Negative sine of whatever that thing is, right? The inside stays the same. And here's where it gets tricky. I now have to take the derivative of the inside. Okay, the derivative of x is 1. The derivative of y is dy dx. Because we're taking the derivative of y with respect to x. When we take the derivative of x with respect to x, well, dx reduces to 1. But the derivative of y with respect to x is dy dx. Okay, and then we've got the derivative of 0, which is 0. So that was kind of nice. Oh my. I'm going to distribute here. I've got 1 minus, okay, this times 1 is just itself, sine of x plus y. And then minus again. It's this whole thing that's getting distributed to the dy dx. So minus dy dx times that sine of x plus y. Okay. I want to solve this for dy dx. I'm going to scroll up. Boop. Well, let's subtract 1. Subtract 1. And add the sine of x plus y. Add the sine of x plus y. Okay, what happens? Over here we've got negative dy dx times the sine of x plus y equals, oh, negative 1 plus the sine of x plus y. Okay. Now I'm going to divide by negative sine x plus y. So let's divide by negative sine x plus y. Divide by negative sine x plus y. Oh, algebra, it's good stuff. Let's see. So we divided by the negative, so we're left to just a positive dy dx. I'm moving right here, okay. Well, let's see, we have negative 1 plus the sine of x plus y divided by negative sine of x plus y. Let's take a look and see how we're doing. Wow, that is not an option for any of them. Delightful. Okay. Whew. Well, let's see if we can simplify it down. We have two things divided by, that is one thing, that is one term. So I'm going to divide that one and divide that one because we love math. Let's see what we get. dy dx equals, we have a negative divided by a negative, which is a positive 1 over sine of x plus y. And then a positive divided by a negative. Now if you divide sine xy divided by negative sine x plus y, we're dividing something by itself, but one of them's negative, so we're going to get a negative 1. So we have a minus 1 here. Now let's look. Still no. But you know what? I noticed that a has a minus 1. Take a look at a. Cosecant x plus y minus 1. Why are these the same? Yeah, it's because sine and cosecant are reciprocals. These are equivalent. This is the same as the cosecant of x plus y minus 1 because the reciprocal of sine is cosecant. That was a tricky one to match up, right? Yeah, good stuff. Okay, let's see what's next. That was 44. Ooh, 51. Just on the next page. 51, feeling good. Ooh, we've got x squared plus y squared equals 25. We have the point 0, 5. Notice the point works there, yeah? 0 squared plus 5 squared is 25. I like it. Okay. Oh, and we're finding the second derivative of y with respect to x both times. Why? Because you wanted implicit differentiation. So I showed you an implicit differentiation, first derivative, and now we're going to do an implicit differentiation, second derivative, because it's delightful. Well, to get the second derivative, I have to take the derivative twice. So let's get the first derivative. We've got a 2x plus, right here, 2 times y times dy dx equals 0. When you take the derivative of y with respect to x, you get a dy dx. Here we're taking the derivative of x with respect to x. We don't get a dy dx. There was no y there. That one has that. Okay, I'm going to solve this. I'm going to subtract 2x. We've got, oh my, 2y times dy dx equals negative 2x. I'm going to divide by 2y. And we get that dy dx equals negative x over y. That is the first derivative. I need to take the derivative again. So now, the second derivative of y with respect to x both times is quotient rule. The derivative of the top times the bottom minus the top times the derivative of the bottom, and the derivative of y is dy dx. All over the bottom, which is y, squared. Okay. Whew. Well, here's the tricky weird thing with second derivatives on implicit. In this dy dx spot, we have to put what dy dx equals. dy dx is negative x over y. That's going to go there. It is. And we have a point. We have a point 0, 5. Don't forget about that. 0, 5. Let's keep going. So the second derivative of y with respect to x both times is negative y plus x times dy dx. And dy dx, oh my gosh, what was it? Let me look at my paper over here. Negative x over y. See? It was scrolled up. Here you go. all over y squared. We have a point. Let's plug in that point. Yeah, I like numbers. Let's plug in the numbers. See what we get. Negative y is 5 plus 0 times negative 0 over 5. No such thing as negative 0, but that's okay. This is all just 0. All over 5 squared. Oh, feeling pretty good. Negative 5 over 25, negative 1/5. Is that an option? It is! Option D, as in delightful. Feeling good. Let's see what's next. Oh my. Is there another one? I think I was going to do one more. Yeah, 75. Okay. Last one I'm showing you in this video, number 75. Why am I doing so much implicit differentiation? Because you asked for it. You're welcome. Okay, whoo. Chain and implicit, I like it. Let's take the derivative of sine. That is cosine. And you know what we do? We leave the inside the same. But then, we're going to multiply by the derivative of the inside. And that inside function is a product. We're going to have to use product rule. We get to use product rule. Okay, derivative of x is 1. Leave the y alone. Plus for product rule. That's right, we're taking turns because we're fair. Leave the x alone. And the derivative of y is dy dx. Whew, feeling good? I am. Okay. Derivative of x is 1. And I'm supposed to solve that for dy dx. Well, let's divide by cosine xy on both sides. Get rid of that multiplication. Divide by the cosine of x times y. Divide by the cosine of x times y. Yeah? Okay. 1 times y is just y. So we have y plus x times dy dx is equal to, what's the reciprocal of cosine? Yeah, secant. Secant of x times y. Okay. I'm going to subtract y. Let's see what happens. Oh, I can't see. Oh my gosh. I think it was x dy dx. I think I had secant of xy, and then we subtracted y. Pretty sure. But I'm feeling a little nervous about it. Okay, let's divide by x. dy dx, that's the derivative of y with respect to x, is the secant of x times y minus y all over x. Oh, cross some fingers here. Oh, yes! Option C. Didn't even have to move it around. Feeling good. Feeling good. Okay. Oh, so those are some of the problems from your packet. I hope you're having a delightful time reviewing derivatives and getting ready for your AP exam. I miss y'all. Have a great day.